Okie doke, guys. This is part 2, questions 11 through 20 on practice quiz 5.3, 5.4. Let's jump to number 11. Number 11 says, which of the following could the above graph be? Now, if we take a look at the graph itself, it crosses the y-axis at 2. So the y-intercept is 2. How do you find the y-intercept? You set x equal to 0 and solve. So the y-intercept of any standard form polynomial equation will always be the c value, the constant, and all of these are 2, so that really doesn't help us in this case. We do know that there's one arrow down, one arrow up, so that means that it's an odd degree function. So we know it's an odd degree function, so that means we could eliminate this last option. Because of the degree 4, it can't be it, so eliminate that last one. Not only that, if we think about an odd degree function, the most basic type of odd degree function would be y equals x to the 1 power, which is simply the line y equals x. And the line y equals x obviously is a diagonal going that way and this way, which has n behavior in quadrant 1 and quadrant 3. Okay? So we know that this odd degree function has a leading coefficient that's positive. So this guy that has the same n behavior in quadrant 3 and quadrant 1, it must have a positive leading coefficient. And as you can see, this one's negative, which would cause the n behavior to flip. Okay, so you could eliminate the ones that have a leading coefficient that's negative. So you could eliminate this guy, you could eliminate that guy. So we're down to 2 options. It's either this long one or this simple one. And what we could do is plug in a nice coordinate, like let's say the coordinate -2, comma -2. So if I plug in a -2, will I get out a -2? And let's try that with this one, since that's an easy one to do. Plug in a -2 right there. -2 times -2 is positive 4, times -2 is -8. -8 plus 6 is, -8 plus 2 is -6. And that's not the input -2 does not give us the output 6 or -6. It's actually -2. So this one is not it either. And if you'd like, you could verify and plug in -2 right there, -2 right there, -2 right there. Do all that math, and it should give you the output -2. Okay. Another way of checking it is to use synthetic substitution. For example, if you want to input the -2, you could input the -2 right in there and see if it gives you the output -2. And you would take your coefficient term, the coefficient of each term, 2, 9, 12, and 2. 2, 9, 12, and 2. And we're going to use synthetic substitution. And whatever you get over here will be the correct output. And of course, the correct output we want is -2. Let's see if that happens to verify it. So we have 2 plus nothing is 2. And -2 times 2 is -4. 9 plus -4 is 5. And -2 times 5 is -10. And then 12 and -10 is 2. And -2 times 2 is 4. And 2, no, I'm sorry, -4, right? -4. Because -2 times 2 is -4, and then 2 plus -4 is -2, is -2. And as you can see, this output -2 is this output -2. So we verified that this is the correct answer. Let's move on. Same type of question, number 12. Let's see which one is correct. Now, right off the bat, we know that there's an odd degree function. We know that the leading coefficient is positive. It's odd degree because there's an odd number of arrows down, an odd number of arrows up. If it were 2 arrows up, it'd be an even degree function, or 2 arrows down, even degree function. But there's an odd amount of arrows up and down, so it has to be an odd degree function. It cannot be the degree 4, so you could eliminate that guy. All the rest, you could also eliminate this guy because of the even degree. You could eliminate it. So we're down to these 3 options that all have the power of 3, the degree 3. And we know that the n behavior of an odd degree function that has a leading coefficient that's positive So once again, we have a regular xy plane, and if I were to graph the easiest type of odd degree function, it'd be y equals x to the 1. That produces a diagonal line crossing right through the origin and behavior in quadrant 1 and quadrant 3. Okay, so any odd degree function that has a positive leading coefficient, there is no negative sign, will have end behavior in quadrant 1 and quadrant 3. So this has end behavior quadrant 1 and quadrant 3, so that must mean that the leading coefficient is positive. So it cannot be a negative one, so you could eliminate that one as well. So we're down to these two options. What I recommend is picking a coordinate and seeing if it works, right? So let's pick the coordinate -1, -3. That's coordinate -1, comma, -3. So if we plug in a -1 right here and right there, and if it gives us a -3, then this must be the answer. If I plug in -1 right there and do all that math and it gives me -3, then this one must be the answer. One of them should work, one of them shouldn't, right? So when we plug in a -1 there, -1 to the third is -1. When I plug in a -1 right there, 2 times -1 is -2. -1 and -2 is a -3, so I know that this one works. If I were to plug it in up here, it will not work. I think. -1 cubed is -1 times 2 is -2. Over here, -1 squared is 1 times -3 is -3. So we have a -2 and a -3, it's -5. -5 plus 2 is also -3. That is interesting. Okay, so we need to test another point. How about we test the coordinate 1, 1, see if that works, okay? So if I plug in a 1 for x, will I get out a 1 for y? So we're testing another point, 1, comma 1. So if I plug in a 1 right here and a 1 right there, will I get out the answer 1? That's not true. So this did not work. If I plug in a 1 right here and a 1 right there, and I do the math, 1 right here, 1 right there, do the math, that's really going to be 2 times 1 is 2, -3 times 1 is -3, 2 minus 3 is -1, -1 plus 2 is 1. So this is the correct answer, not this one. Again, when I tested the point -1, -3, both of them worked. So I'm glad I actually tested both. I didn't go with the first one. I tested both, -1, -3, it worked for both, so I needed to pick another point and see which one it works for and which one it doesn't. I picked the point 1, 1, it worked for this one, it did not work for this one. Let's move on to question number 13. We have a graph right here, it says select all true statements. The leading coefficient must be negative. That's true, because if both arrows were opening up, the leading coefficient's positive, but because they're reflected over the x-axis down here, that means that the leading coefficient is negative. So that's for sure true. The degree must be an even number and at least 4. For sure it's even because it has 2 arrows, an even amount of arrows opening down, so for sure it's even. But to determine whether it's at least 4, you gotta count the number of directions it goes in. It goes up, that's 1 direction, down, that's 2, up 3, down 4. So yes, the degree must be at least 4. So far, both of those are correct. The absolute minimum value is at 0, 2. Well, this is definitely a minimum value, right? It's going up and then it goes down and then it stops. That's the lowest point. But that's the minimum value relative to this little tiny curve. Because as you could see, there are other values that are way lower than that. So it's not an absolute minimum, it's a relative minimum. So that word, absolute minimum, makes it a false statement. The next one, the relative maximum is about 1.5 and 5.2. So if I go to 1.5 and I go 1, 2, 3, 4, 5.2, yeah, that sounds right, the relative max. Oh, wait a minute. Is this relative max? This one's a relative max. This is the absolute max because there is no other point higher. This is relative, that's your max value. This is a relative max value. So keep that in mind. This word right here, relative, is messing it up. That should just say the maximum value is at about 1.5, 5.2. That word relative messes it up. If we say relative max, they're talking about this one, the one at -1 and 1.9. -1, 1.9. That's your relative max. But this one over here is the absolute highest point of this entire graph. This is the absolute max, not relative max. Last option, last sentence, statement, has 2 real zeros. Does it have 2 real zeros? That means it crosses the x-axis 2 times. That is correct. So your 3 options that you would select are the first 2 and the last one. Number 14, select all the true statements. The leading coefficient must be positive. That is true because it has end behavior down here in quadrant 3 and quadrant 1. We know it's an odd degree function. We know that if the end behavior is down here and up here, then the leading coefficient must be positive. So let's bubble that in. That's for sure true. The relative max is at 0, 2. 0 on the x, 2 on the y. It is the relative max. Very important that we understand that it's not the absolute max, right? Because it does go up forever. It's the relative max. It is the maximum value relative to this little tiny curve. So that's a relative max value at 0, 2. So I would select that one as well. Moving on, the degree must be odd and at least 3. It's definitely odd because there's an odd amount of arrows opening up or down, and it's definitely at least 3 because of the direction, right? It goes up, that's 1, down, that's 2, up, that's 3. So that's definitely correct, that statement right there. And let's move on. This has one real zero. Does it? A real zero means x-intercept. That does cross the x-axis only one time. So this is correct as well. And the last one, the relative minimum is about 1, 1. And that is true. That blue dot right there at 1, 1 is the relative minimum. It is a minimum relative to this little tiny curve, but not to the whole thing because we know that it does go down further. So that's a relative minimum, not the absolute minimum. So in this case, every single one of these was correct. This next one is a question strictly on end behavior, right? And what we need to understand is when you read x approaching negative infinity, that means to the left. When you see f of x approaching positive infinity, that means up, right? Your f of x values, your y values, and it even says f of x right here, but that's your y-axis. If it's saying positive infinity on the y's, on the f of x's, that means it's going up. So this means as you go left, do you go up? No, you do not. So this is not it. As you go right, do you go down on the y's? Do you go down? No, that one's not it either. Okay? Now these other two are written backwards, so what I recommend if you get confused is to simply read it the way you're comfortable with. In other words, read the x term first. As your x's go to negative infinity, that's saying to the left, your y's go to positive infinity. Is that true? As you go to the left, you go up? No, it doesn't. As you go to left, you go down. So as you go left, this one says you go down. So out of all of these, the only true statement is this one right here. I hope that makes sense. Moving on this question, the degree of the function could be 6. Well, let's think about the degree. It goes down, that's 1. It goes up, that's 2. It goes down, that's 3. It goes up, that's 4. So we know that the degree has to be at least 6. I mean, at least 4. At least 4. So 1, 2, 3, 4, at least 4. Now it's saying that it doesn't have to be 6, or it doesn't say it has to be at least 6. It says that it could be 6. So that does work. At least 4, it means it could be 4, it could be 6, it could be 8. And it cannot be 7 or 9 because it's an even degree function. It has 2 arrows pointing up. So this is a correct answer, or one of the correct answers. And then the next one says the relative minimum value is about negative 0.7, so that's here, and negative 3.4. That sounds about right as the location, but is it a relative minimum? The answer is no. That's actually the absolute minimum. That's the lowest point in the entire entire graph. So this is not relative to a certain part. It's actually the minimum value, not the relative. It's the absolute minimum value. So because of that, because of the word relative, that would make this a false statement. You wouldn't pick it. If it would have said the absolute minimum value, then yeah, it would have worked. What else does it say? It has one real zero. Does this one real zero means that it only crosses at one point? And as you can see, it crosses at 2 points, not at 1 point. So that's definitely not true. The relative maximum value is at about 1, 4.5. So 1 on the x, 1, 2, 3, 4.5. That is actually a relative maximum. It's not the absolute because it does go higher than that with the arrows, but this is definitely the maximum relative to this little curve. So this is a true statement right here. And then it says the absolute minimum is at about 2.25, 1.5. So 2.25, 1.5, that, or 2.25, 1.5, that's not the absolute minimum. That's actually the relative minimum, okay? So the absolute minimum is down here, absolute minimum. The relative minimum is up here, relative minimum, okay? So I hope we understand that the word absolute makes this a false statement, so I would not pick that. It's only those two true statements right there on number 16. If we take a look at this graph, and we need to select the correct statements, it says the input -2 will provide you with the absolute max value of -2. So what does it mean the input -2 gives you the output -2? What does that mean? That means that the coordinate on this graph is -2, -2. So if I do plug in -2 on the x, do I get out a -2 for the y? And the answer is yes, because there's a coordinate -2, -2. Inputs are your x values, outputs are your y values. So the input -2 really does give you that output of -2. However, the word absolute messes things up, because this coordinate 2, -2, or -2, -2 is not an absolute max value, because we know that the graph goes up forever. So this is a relative max value. So if this would have said relative, I would select this as a true statement. But because it says absolute, I cannot pick it as a true statement. This whole thing's wrong. Okay? Moving on. The leading coefficient must be positive. What do you guys think about that? Is the leading coefficient positive, depending on your end behavior down here in quadrant 3 and up here in quadrant 1? Yes, it is positive. So you would select this one for sure. How about this? The input -1 will provide you with the relative minimum value of -3. -1, 1, 2, 3. It says the input -1 will provide you with the relative minimum. Is this a relative minimum? Yes, it is. So that is absolutely right as well. And the last one, the input 2 gives you the output 6. Does the input 2 give you the output 6? No. You see how that's way steeper? It's not going to go from here to there, right? Right here's the output 6. The input 2, output 6 is right there. It's not going to bounce over there. It's going to keep going up. It'll eventually get to that x value, but it's not. It's steeper than that. So this cannot be a true statement. So out of all these, only these two are the correct ones. Okay, so what is the smallest possible degree of this function? That all depends on the direction that the graph is traveling. So here's one direction. From left to right, it's going down. That's 1. Goes up. That's 2. 3. 4. 5. 6. So what do we type in? We type in 6, hit enter, and you will get this answer correct. The degree of this polynomial function must be at least 6. It could be 8, it could be 10, but it has to be at least 6. This next one, let's select all the true statements. What do you guys say? The leading coefficient's positive? Yes. It's an odd degree function down here and up here. We know that if it does have an odd degree function down here, end behavior of down here and up here, it is a positive leading coefficient. So this is correct. It says there are 3 relative max values. Well, let's see. What do you guys think? True or false? Here's a max value. Is that the absolute max or is that relative? Relative. Here's another max value. Is that relative or absolute? Relative. This one's also relative. So yes, it really does have 3 relative max values. And you know what? This was a typo right here. I think, yeah. If you have this on your practice quiz, go ahead and select both of them, right? Select this one as well. It says the same thing. Select both of them since they're both correct. But I believe, I'm not sure if it's on your quiz or on the next quiz, I already made it a change where this one reads, there are 5 real zeros. So If this said there are 5 real zeros, what would you say? That would be true, right? There is 1, 2, 3, 4, 5 x-intercepts. That means that there are 5 real zeros. So if it does say there are 5 real zeros right here, go ahead and select that as a true statement. And if it does repeat it, just select it again anyway. I'm not too sure if I've made that change already on your quiz. What about the next one? So the next one says the range is y equals all real numbers. It really does go down forever and up forever. So yes, the range is y equals all real numbers. So far, every single one of these has been right. How about that last one? The degree of this function must be at least 7. Yes, it is, right? Up, that's 1, 2, 3, 4, 5, 6, 7. 7 directions that it went, so it is at least 7. So every single one of those were absolutely true. You would select all of them and then submit. Last question. The domain is x equals all real numbers. Does this graph go to the left forever and does it go to the right forever? Yes, it does. So the domain is x equals all real numbers. So far, this part is true, but let's continue reading. It says, and the range is also all real numbers. And we know that that's not true. Because now if we had an arrow going down and an arrow going up, then yeah, the range would be all real numbers. But we know that this is not true. The range is actually at about 5.2 and below. So y is less than or equal to 5.2. That would be the range. The range is definitely not all real numbers. So that makes this statement false. You can't select the whole thing, okay? Because a part of it is false. Move on to this next part. It says, as x approaches negative infinity, that means as you look to the left, the y values go where? Up or down? According to this. Down. So as you go to the left, it does go down. So that is a true statement. You would select that guy. How about this? The degree must be at least 6. What do you say? Must be at least 6. That's not true, right? It could be 6, but it doesn't have to be at least 6. It has to be at least 4, the number of directions that it's traveling in. It goes up, that's 1. It goes down, that's 2. Back up, that's 3. Back down, that's 4. So it has to be at least 4, not 6. So that doesn't work out. The absolute minimum value is negative infinity. What do you guys say about that? What's the absolute minimum value? It continues to go down forever. So yeah, that would work. The absolute minimum value is negative infinity. So those two would be selected, nothing else would be selected, and that is the last question on this practice quiz.